Okay, in this class, I'm not going to tell you the topic as well as the learning goal. In fact, we will know the topic and the learning goal by ourselves towards the end of the class. So you still are looking at the axis which I defined already. So we have got the buildings on a straight line. Now let's go back to the scenario again. Now instead of a boy who is traveling from Amazon to Takshila, let's take a girl's scenario now. So in the morning, the girl is going to start from Danube and she's going to reach Takshila. So for example, let's take that she starts from Danube at 8:45 a.m. in the morning and her position is 1. Yes. Please remember, we use the symbol S for position and displacement in physics. So our position is S1, which is going to be plus 200 meter. Now, this position of hers is called as the instantaneous position. We call that as instantaneous position. Now, what does the word instantaneous mean? Instantaneous means that she was at 200 meter mark when the time was 8:45 a.m. Please remember, I am using the word at, which means at that instant in time she was at 200 meter mark. Now, let's imagine that she reaches the Takshila at 8:47 a.m. So which means S2, which is her final position, is going to be minus 200 meter. So to just explain what I just did, this is also called as the instantaneous position at 8:47 a.m. Now, how do I find displacement? So what's going to be displacement? What's going to be displacement? We know displacement is nothing but S2 minus S1, which is final position minus initial position, and that, let's say, is given a symbol del S. So you have got displacement to be S2 minus S1, so it becomes minus 200 minus of plus 200. So you get minus 400 meter. So that is our displacement of the girl. Now what is del T? Now del T here represents the time taken for the girl to move from Danube to Takshila. So how much time does she take? So when she was in the final position, it was 8:47 a.m. When she was at the initial position, it was 8:45 a.m. So the time taken is actually 2 minutes. So if I have to write it in seconds, that becomes 120 seconds. So now we have the time taken for her to displace herself by 400 meters towards the left. Now my question to you is, using these two quantities, which is displacement and time taken, is there a way to calculate how fast she was moving and in what direction she was moving? So if you quickly think about it, you will realize the fact that it is going to be del S by del T, and that is mathematically equals to minus 400 by 120. This is meters, this is in seconds. So you get minus 3.3 meter per second. And this quantity is what we call it as velocity. Quickly, can I just call it as velocity? I'm going to pause for a moment so that you can think about it. Now, the answer is no. Why I can't just call it as velocity? Because there is a good chance that she would have stopped on the way from Danube to Takshila, or rather she may not be traveling at a steady velocity or at a steady speed throughout our journey from Danube to Takshila. So that's why I have to call it as average velocity. So average velocity is given by displacement divided by time taken. So that is the topic today. So average velocity is what I wanted to teach you, and the learning goal was to find average velocity. As you can see, this magnitude 3.3 is talking of the speed with which she is moving from Danube to Takshila, while the negative side is talking of the direction in which she is moving. Please look at the fact that the negative sign of velocity and the negative sign of displacement are one and the same, which means the direction of velocity and displacement will always be same. Thank you.